Okay. Sorry, feel at home. And let's welcome Robbie. Robbie, thank you very much. And I'll hand it over to you now. Thank you. And for anybody, my name is John Driver, and welcome again. Welcome again.
Thank you, John. And I want to thank our good friend Erin also from TIBCO. Thank you for partnering with the Hive think tank and doing these events with us. So today is the first in a series of 5 events that Hive and another Hive's partner Verizon are doing together. And where is Mark Smith? Mark Smith from Verizon Ventures is one of our partners, and from Verizon we'll have Serhad be the moderator. So you'll see kind of events around mobile edge computing, industrial and IoT type applications, other AR, VR type applications. There's a whole series of topics coming up. So if you're interested in 5G, watch this space. Stay tuned. A few things about the Hive before I hand it over to Serhad. So the Hive think tank is a thought leadership forum. So we bring together corporations, entrepreneurs, and thought leaders across multiple different tracks. And so with the help of Verizon, we've created a new track on 5G. And so we're excited to kind of launch that today with this event. We have over 10,000 people who have physically come to our events. There aren't many women here today, but we had an exclusively women's event 2 weeks back where my friend there joined us, and it was just a monster of a success. And so you'll see us do events every other week. So I just wanted to mention some. Along with another partner, IBM, we have a live webcast this Friday at noon. And if you're interested, go to our meetup page. Production-ready open source AI pipelines on Kubernetes. And the CTO of the Hive, Mohan Reddy, will be the host there. How many developers do we have here? 1, 3 or 4 developers. You guys are invited to a party. This is on Monday night. Go to our website again. It's a call for code is an initiative that a number of people support. VMware supports, IBM supports. They're coding for sort of some cause, usually sort of humanitarian type cause. And so they are having a party, a fancy party in San Francisco, exclusively for developers. And there's going to be kind of a tier 1 musician. The rumor earlier was it's going to be Maroon 5, but they are not it. It's someone else. So I hope if you're a developer, please come in. Please join. In November, early November, we'll have a panel on social implications of robotics. So a lot of people who are working with machines, who are working with bots, it could be an assist, augment, and automate is coming mode, are getting depressed, and so this event will focus on that, on what is sort of the impact on the humans when you have robots in the workplace. As you probably all know, 10 years from now, 70% of the business process jobs are going to be automated. So it's a real issue. And a partner of ours is doing a conference on AI. It's called AI Frontiers Conference 2018. And so if you're going, there's a 25% off code. P25 Hive is the code. But if you're not able to find it, reach out to us. The Hive is an early stage venture fund, and it's also a studio to create companies. We are very focused on AI applications in the enterprise, in the industrial segment, financial services, and one of our LPs is Verizon. So we do a lot of things with Verizon. So that's it for today. I want to thank my colleagues, Maddie and Mohan, for also helping me do this event today. And of course, Serhad and Serhad's team for making this happen. With that, I'd like to introduce Serhad. just a little bit on logistics. So I think what we plan to do is have the panel discussion and then keep the kind of Q&A to the end. So we will have a chance to ask lots of questions.
All right. Thank you, Ravi. Hi, welcome. First of all, thanks to TIBCO for hosting us and the Hive for organizing the event. So what I do at Verizon is I focus on building 5G ecosystems. What that means is once the network is deployed, what is it going to be used for rather than build it and they will come. What we focus on is figuring out what those use cases and applications are and how will they take advantage of the new capabilities offered by the network and who should we partner, how can we validate those use cases, build proof of concept, who should we partner. That's the focus. So a lot of application and use case and services is what I'm primarily interested in. Today we have esteemed panelists, serial entrepreneurs. So without further ado, I'd like to bring them on stage, have them introduce themselves. Anton, Constantine, Udayan, and Steve. We have only 2 microphones, so yeah, anywhere. So we can pass the microphone around. So Anton, maybe we can start with you first. If you can tell us what you're focused on, your background, experience, and we'll jump into the 5G questions after that.
Okay, sure. Thanks for having me here. Just got off a plane and luckily made it in time, which was delayed. Let's see. I've spent the last few years in the 5G world at a wireless startup up here and recently changed, and I'm moving to San Diego to join a new startup called XCOM. Can't tell. Interesting company. It was formed a few months ago by the former top leadership from Qualcomm. So there's been some changes at Qualcomm. We're building up a team focused on 5G and beyond 5G, I'll say, and in particular in the areas of mobile edge compute, which I'm looking forward to talking about, in particular things like industrial IoT applications, AR, VR, and robotics. So some of the things that you really can kind of touch and feel as opposed to being much lower down at the stack. And I think it's interesting for consumers to understand what goes beyond just high bandwidths that 2G, 3G, and 4G tend to have brought us.
Thank you for the invitation. I'm glad we're here, and thank you very much for attending the Hive event with Verizon sponsoring. My name is Constantine Polychronopoulos. It's a fit just to pronounce my last name, but if you break it down to poly and chrono, it becomes manageable. And I've spent the last, about the last 19, almost 20 years of my life essentially working with telcos, small telcos, etc. I used to be a faculty member at the University of Illinois, so I started my academic career in systems software primarily. Spent there, a lifetime at the University of Illinois, and in 2000 I started a company here in the Bay Area, which managed to bring in about 160 Tier 1 operators who were focusing on network optimization, and I'm proud to say that we were the first ones to enable high fidelity, high quality video streaming to feature phones and eventually to mobile phones. Since 2017, I've been working as the CTO of Telco and FE at VMWare, which is focusing now increasingly on the telco ecosystem. Thank you.
Thank you. Hi. So my name is Udayan Mukherjee. I'm an Intel Fellow. So I look into all the technology and platform development for radio access networks, so 5G base station, 5G core, UPF, and mobile edge compute platforms. We worked with Verizon a long time ago. We worked in the 5G TF space. specification before even the 3GPP, 5G NR spec started. So we work closely with the spec development and now silicon and systems addressing some of the challenges of low latency and some of the high throughput use cases that we are planning to run on this 5G. Just one additional stuff, I mean, when 5G is such a wide angle, this thing, it's not just the connectivity, and I think you, Anton, you talked about that this is about compute aspects of it, and we'll discuss more on this. And that's why these use cases become very interesting. Thank you.
Hi, my name is Scarlett. I work with Nokia, and really I'm a technical liaison. I've had the privilege of working with Verizon, primarily looking at advanced architectures. So I've been working with them on 5G for about 4.5 years now, from the incubation stages of just trying to see what 5G would be through today, breaking up the first live systems of the network. So it's a great point that 5G is and has to be something more than just a connectivity play. It has to be something different so that use cases can be really unique and drive some real value in the network for everybody in the value chain. I think we have to drive beyond that. So right now, we're going to turn things on and get things going, which is where you have to start. But there's a lot of work to go. In fact, I think there's a lot more 5G development to come than has already occurred. Because we're just at the point of this connection technology.
All right, great guys, thank you. I think we're going to get into the 5G features, talk about the technology a lot, but I'll jump to the end. Maybe let's cover what are the benefits and the results for 5G. Maybe Constantine, I'll start from you. Why we need to go to upgrade to 5G now? Why now? LTE seems working fine, so what's the need?
You say 4G LTE is working fine? Well, the last time, I don't know if it happens only to me, but there are so many mobile broadband, right, for higher bandwidth. We all can relate to that. We want to have higher speeds, better quality video, and we always find a way to cram the pipes. But what's hidden, and it's not obvious, is the use cases that 5G is going to enable. We cannot do it on 4G. I'm a very strong proponent, believer, in the need to softwareize the network, to really propel the network to the 21st century, so that you have the ability to provision services very quickly, move with the technology. And we live in a world where the technology moves at neck-breaking speeds, okay, across the board. So 5G, I think, is simply a way to keep up with technology evolution. Otherwise, the notion of ubiquitous, omnipresent connectivity is going to remain a notion, not a real reality.
Got it. You want to chime in, Udayan?
Sure. I mean, looking at the amount of data getting generated right now. I mean, you have billion plus people already in the Facebook and stuff, but next generation of internet is not about that what I am posting or I am doing something. It's about machine to machine. Machines are generating the data. Connected factory, connected planes, automotives. Those are generating data. What do you do with the data? So you have to transfer the data somewhere. You have to make something happen out of it. So a lot of those requires huge amount of throughput. And then these new use cases like autonomous driving and others becomes low latency applications. Now you bring the connectivity, you have to serve the connectivity there. Now if you look into the factories, General Electric and Bosch and others, they used to have network, but they're all proprietary network that they want to run. So that's why the 5G kind of the grounds of design of not just enhanced mobile broadband, but bring in other use cases from IoT, mission critical IoT, and that expands the scope.
Great, thank you. So by one measure, if you think about going from 4G to 5G, that's like 25% improvement. Is that really the case? Like how much are we improving the performance?
So this is where the 5G is many things discussion has to happen. So you have to look at 5G in the different bands to understand where you're going to get the gain. So 5G is going to impact sub 3 gigahertz, which is your classic LTE bands, but again, megahertz or megahertz, there's not a lot of more you can wring out of it with the air interface. Millimeter wave is the new frontier, especially here in the US. It's going to go first, adding substantially more bandwidth than we've ever had before. But it's a different challenge to solve. So if you look at 28 gigahertz, for instance, you can get an 800 megahertz service, which is 8x what most entire carrier deployments of LTE are. So you're talking about a fundamental, huge increase in bandwidth. That's possible. The other thing that's really interesting is mid-band. Here in the US, unfortunately, we're a little bit behind. The rest of the world has gone with mid-band first. They've kind of gravitated towards that. What I mean by mid-band, this is the 2.5 through, say, 4.5 gigahertz range, which is really compelling as well. I think it's that tapestry that'll give us the performance. So if you look at millimeter wave, the performance is massive, but the challenges of coverage are going to be significant, and it's going to take some time. Mid-band is a great glue, and you're still talking about, if you look at the C-band, which is being looked at by the FCC currently, that's a 500 megahertz band. That's a great place for us to augment as well. So the numbers are massive. You're talking 4, 5, 8. You get the 39 gigahertz, you're talking about 1.4 times what we've ever deployed in LTE. So the capabilities are massive. It's not really my focus because I think that's great and it's a great tool and enabler, but the network behind it has to be able to handle it. And we can't just try to cram that massive access down the same architecture we used in 4G. We must evolve to a 5G architecture for lots of reasons. It enables the business case, and you're not going to want to handle the network the same if you're doing a massive data transfer versus doing ultra-low latency. They're very different animals, and the network has to be sliced, and we'll talk about slicing, I think, a little bit later on the questions, but network slicing, these things are all the important parts. I mean, the air interface is a nice place to start, and we have to start there because obviously you have to have it. But we really got to move it into these other enablers that are in the 5G core that I think are the more fundamental change. We could have done 28 gigahertz with 4G. There's no reason why we couldn't have. But you can't do ultra-low latency in the biggest sense. Everything can be done with LTE, but it's about scale. It will drive into industrial strength. So I think that's really where the performance, so it's going to be a wide range of performance improvements you see. Air interface, substantially more bandwidth, but also much better performance in the app space if you do it right, where ultra-low latency is possible next to massive bandwidth push. That's what we need to get to.
Thank you, Steve. Anton, for the average consumer or folks in the audience, can you help us understand, educate, will the consumers get better different services, or is 5G more focused on enterprises? What's your take?
I think this is probably the most interesting question from a consumer perspective. Living and breathing 5G like most of us do, we hear about all these other use cases, and we'll get to them. But for consumers, you are not likely to see the same kind of leaps that you saw going from 2G to 3G to 4G. Really, 5G is addressing new use cases and new verticals. And I mean, don't get me wrong, there are things that people will see in terms of coverage. Constantine's problem with coverage, partly due to the fact that when I looked at his phone, he does not use Verizon. So that might be part of the problem. Neither do I, so I'm sorry. We're suffering for that. But certainly there'll be increases in coverage. But like Serhad said, by some measure, even by some operators in the sub-6 gigahertz band, on average, you're not getting much more than 25%, 30%. You can always push it higher. So it's not going to be some massive revelation that you're going to say, holy cow, I can do these amazing new things. What's going to happen is when you do have access to millimeter wave, what it's going to do is it's going to help the network. So the network, you'll be able to offload to millimeter wave, and there'll be more bandwidth, more coverage available for sub-6 gigahertz. So overall, people will see, I think, better throughput. But keep in mind that millimeter wave has its own set of unique properties having to do with line of sight or very, very specific environments, channel environments that it has to overcome. So for me, just going back to the question, the most interesting part of 5G is these new verticals. And this has been identified years ago at the start of 5G. And I think one of the most interesting ones is the machine-to-machine applications. In particular, some of the stuff that we're looking at that I mentioned briefly are robotics, AR, VR, and mobile edge compute. And if you think about it, these new paradigms have brains on these robots doing advanced navigation. You have venues where people are wandering around with VR and AR headsets, And they have some very unique properties. They require very high bandwidth, they require very high reliability, require very low latency, and they require dense numbers of users. Those things have not been done before in any G. 4G certainly can't do it. And so that's one of the things being addressed in 5G. And the other thing to remember is there's multiple phases to 5G. So you won't necessarily see everything all at the front. The front is focused on EMBB, that's release 15 of the standard. Release 16 has other things it's addressing, better coverage, better MIMO capabilities, and industrial IoT type applications.
Thank you, Anton. So we had 5G in our labs for a while. We did lab testing, field testing, and then we started deploying in 4 cities in the US. And we're actually going to put a node into our Hamilton Avenue in Palo Alto and then start working with the startups. So that's all good, but what's your take on 5G service being really accelerating, going exponential, and available to maybe not ubiquitously, but majority of the population? In terms of timeline, where do you see, what does your crystal ball say?
You mean in terms of commercial offering?
In terms of commercial offering.
Yeah, I believe that we're first going to see 5G in the so-called NSA, and I don't mean the for mid NSA, the non-standalone, right? Which is 5G radio and 4G packet core, or 4G infrastructure, right? Which is not today suitable to carry this kind of use cases, right? We need to have the notion of truly softwareizing, cloudifying essentially the infrastructure, which will allow us to do all the cool software-defined things like network slicing, and therefore offer end-to-end quality of service that is an absolute must-have for some of these use cases, right? There are, you know, in some verticals, we see basically the industry going ahead of the network evolution. Some of the auto manufacturers, like Mercedes-Benz, retrofit their cars today with transceivers that allow them to create ad hoc radio networks and communicate with each other. The applications there are very limited. Imagine now all of these cars hanging off a 5G infrastructure, right? You need to be able to slice the network, dedicate, and adjust based on the number of units that connect to the network and the aggregate amount of bandwidth that they need, right? So the network needs to be agile, both in terms of resource allocation and behavior and quality of service. So if I have a hotspot in one part of the network, I need to be able to migrate services or migrate users or be able to, jump off to a public service and create, a presence there, like in AWS or Google or whatever, right? And extend elastically my network and my capability. So 4G core today doesn't offer that. Not to mention the need to take these humongous data centers and even the central offices and push them very close to the access points to address the issue of latency, which poses a huge problem on the control side. And one of the big advances that 5G makes is to make a clear split between the control plane and the data plane, right? The so-called CAPS.
All right, got it. So let's peel the onion a little bit more. You talked about RAN slicing. Udayan, maybe you can educate us on why do we need RAN slicing and what are the particular applications it's going to need? It's going to take advantage of this, and how will that 5G future look like with RAN slicing? What happens if you don't have RAN slicing?
Right. And again, if we look at network slicing in general, and we ask several different people about the definition of what network slicing is all about, we'll get probably slightly different definitions. RAN slicing is one thing. I'm focusing primarily on slicing the rest of the infrastructure and doing so in a way that works hand in glove with RAN slicing. In RAN slicing, I believe where things are going to end up is by separating the so-called data unit from the control unit, so we have distributed BUs and centralized CUs that become intelligent and allow us to optimally schedule basically the time frames, the frames, right, across the variety of different connections that have different quality of service demands, right? So you need a brain to do things that unless the rest of the infrastructure provides also the rest of the slice in an end-to-end fashion, right? And that takes us down the path of provisioning such an end-to-end slice. What does it mean to provision, right? How do I orchestrate and overlay completely end-to-end? Think of it as a virtual mobile network operator, which can be a use case in IoT, industrial IoT, for example, right? But I want to provision and I want to make that network fully segmented and existing on purely virtual infrastructure. I don't want to go buy gear and put them in my data centers. I want to create it on existing physical infrastructure. And if I need to again jump off to a public cloud, I can do so, right? And the separation of control functions from the data pushers, the data forwarding plane, allows us to do that, to create very powerful SDN controllers, create meaningful ways of doing orchestration, etc. But I believe we're just at the beginning of that journey.
I have a little bit evolved definition and understanding on this. Slicing itself is an end-to-end concept. 3GPP, the release 15, release 16 is getting there. In SA, or system architecture, kind of a subgroup defines elements of network slicing, network and subnet. But imagine this, in data centers, we have virtualization. It comes from VMware, which is basically lives and breathes on this. Resource utilization. Now, 5G is not just enhanced mobile broadband. It's about URLLC, ultra reliable, low latency ones, massive IoT. Each of these has different characteristics. Enhanced mobile broadband, huge amount of data. Regular IoT, quite a bit of frequent data, but less amount of data processing. URLLC, huge amount of stringent requirements on latency. Even in the specification, the 5G enhanced specification, there is this concept of mini slot for URLLC, which is not there for EMU. Now, what does all these jargons mean? That I have to actually provision and do the resource allocation appropriately. So you virtualize the complete internet network, essentially, and do the resource allocation appropriately. In RAN, for example, as the platform, the silicon that we are developing in Intel, you can do a resource allocation about your memory, your cache, your bandwidth, your CPU, cycles to any granularity. So essentially, you can create a kind of a virtual network, which you call a slice, end-to-end, from RAN to core to beyond, to actually serve an industrial applications. For some of these applications that is low latency, you may do a local break-off from UPF, which is a concept in core network, to actually do some local processing, as opposed to taking it all the way to some centralized core. So a lot of these things are possible now because of the specifications in the core network and RAN. The other thing is that it is there in LTE as well. If you look into what is the base station do in network, you do L1 processing, and then you go to the packet. By the time you do PDCP, if you just go PHY, layer 1 and layer 2, and then by PDCP, GTP, you already have packets. You have IP packets. You can do anything on the packet. Now, whether you can do it, or the base station was closed, whether you get access to a packet, that's a different story. But the moment you have an IP packet, you can do anything. If it's not encrypted, if you own that data, you can do deep inspection there. You can do caching. One of the use cases that the original thing that came out of Facebook was they want to do localized caching in the same base station. So, and whether that that mobile edge elements is in the base station or actually in part of the UPF in the core is actually architectural dependent. There are plus and minus in everywhere. But you provide the resource allocation appropriate for that particular use case, and you virtualize the network. So that's essentially what RAN, slicing, for that matter, intel slicing to me.
So let's wake up a little bit. I take an issue. You said evolved definition. I thought you said exactly what I said. Well, I disagree that today we can do everything you said, and you said LTE can do that. Absolutely not. Absolutely not.
So that's evolved. That's the difference. So we cannot do everything in LTE,
right.
but your packets are already there. The mobile is computer aspects of it. You can actually do a local breakout.
Yeah.
Yeah, and do
But,
some function there itself.
So I'll make.
Describe some terms to people like local breakout.
Yeah. So. Yeah. Go ahead.
Yeah. So first of all, let me make a conjecture here that probably will have people up in arms. I believe we are going to fail in the vision of 5G if we allow different, you mentioned the URLLC, which is the ultra reliable, low latency, in our typical communications, in our typical telco jargon. Probably people here don't know that acronym, or evolved mobile broadband, or what's the third one? The MMTPC, which is massive machine type communications. These are the three pillars of 5G, right? And you have, in our community, we think that we're going to address the IoT, many of the IoT verticals with nationwide LoRa networks or narrowband IoT, or, we'll have, right, these are band-aids, okay? Unless we deliver the URLLC and the EMMBB and the MMTPC and all the, whatever the acronym is, on the same physical infrastructure, and get to the point where our software technology allows us to create an end-to-end layer that is segmented and dedicated with strong quality of service, we're going to fail.
That's true. Actually, if 5G becomes the same thing as LTE, and Verizon only gets $50 from me on every month, and then why do you do another huge, capital investment on the 5G side?
Well, increase the
You have to have the use cases.
That's good.
New.
That's why operators need to stop thinking like pipe, like plumbing, and think about the value, right?
Exactly. So it's compute and communications together, and to elaborate on some things, I don't think you will disagree on that one, that what we talked about, that the moment you have the packets, IP packets, which is basically you can get it in the base station, you can actually do some local processing. As anybody was doing it, some people actually, we have some use cases of people doing, but not that much. 5G makes it, architecturally possible to do that processing at the edge, truly, because of the way it is evolving and some new use cases.
All right, so let's take it up a little bit and then we can bring it down again. So Anton, we heard a lot of telecom-specific acronyms. So let's just talk about with 5G, what kind of new use cases, services that will be possible for what verticals? What are your top 3 verticals that you think there will be new services that you can do on 5G but not on 4G?
Okay. I think it's interesting to look and say at a high level what is what do you see as a person, what kind of new applications. So I mentioned a couple of them, but just walking through them gives you a better sense for what does 5G have to do with this. So I'll give you one example. Robotics. So we happen to be working with a robotics company, and you think about the brain that's going on these robots. It's changing the way that things are done within the enterprise, from floor cleaning to restocking to inventory management, all kinds of things. Many of which you won't see because they happen in the evenings or at night in a Walmart or a Costco or something like that. But imagine you've got some machine, it's got some navigation built into it, and it's doing something. And now multiply that concept, because it's very effective in terms of cost efficiency, by 100. And each one of these devices has some big compute brain on it. It's got some big computer. It doesn't scale very well, especially as you extend to different types of robots, small robots, and you want to use the same network. So really what you want to do is you want to take that brain and move it away from the robots. So there's concepts of cloud computing that have been around for a long time, but there's something very specific about this type of communication that is unique to this, and that is that the control and the navigation and the vision for these devices, it's not just robots, this is one example, has to be very tightly controlled. You can't have a robot going, meandering around through an airport and crashing into people. So there's a very tight control loop. That leads to this concept of low latency, which you back in from there to this idea of ultra-reliable low latency communications, this acronym URLLC. So in order to do that, you need to have a wireless link that allows you to move to the edge, to move the compute power to the edge. So now imagine a different evolved version of that, where you've got 100 different robots in some area, but you've got one server or a set of servers on the edge of the enterprise, on the edge of the airport, on the edge of a Costco, on the edge of a Walmart. And it's serving up instances as needed for these robots. So you've centralized the compute, not now in the cloud because of these low latency requirements at the edge. This is where the MEC, the mobile edge compute concept, comes from. But in order to do that and not be tethered, you need these new requirements that cannot be met in 4G. Okay? High throughput, high reliability, because you can't have, it's a completely different concept of reliability. You can't retransmit 10 milliseconds later. Something bad is going to happen. It needs to be very low latency, and it needs to be dense users. So these four things, in my mind, this is the new paradigm. Any one of them has been solved before. Maybe two of them have been solved before, but put all four of them together and you have a problem. Another example is very recognizable, virtual reality. How does virtual reality scale from a tethered device that's in your house, which probably many people don't have yet, but you can imagine the idea of augmented reality, virtual reality scaling to mass adoption. You can't be carrying around a puck computer, or in some of these scenarios, there's these companies that have these backpack computers. They've got high-end GPUs in there. It doesn't scale. Kids can't use them. So how do you make this new paradigm where people might not be using cell phones in the future? They might just have using gesture recognition, and they've got the AR glasses on. You have to remove most of the compute power, and you can't put it deep in the network necessarily because of latency requirements. Again, similar concept. You've got to put it at the edge. Similar concept. You've got very high bandwidth because you've got 1080p currently in both eyes, going to 4K, going to 8K, from 90 frames per second, going to 120 frames per second. These are very stringent requirements that cannot be met either in bandwidth or in latency or in reliability or in terms of the number of dense users. So these are new paradigms that will be solved by 5G.
If I may add that a new paradigm in the 5G world, assuming that we'll be able to deliver all of these verticals, is that unlike in previous generations of cellular technology, we're going to have massive amounts of upstream uplink traffic. Up until now, it's primarily downlink on the smartphone, right? But as we move to IoT verticals where we will need a gateway to aggregate basically data, sensor data or, active agent data, do some processing and then upload massive amounts of data upstream, right? And if this link is going to be a 5G link, then we're seeing a totally, new paradigm shift, right, in this world. Smart cities, right? Ability to smartly, real-time optimize traffic light, behavior, so that you minimize congestion. The applications are essentially endless. The question is which applications are likely to take on root. But if we really take a step back and abstract all the peculiarities of each individual technology, everything boils down to cost performance trade-off. And we see parallels in paradigms that we all are familiar with, right? The world started with mainframes and terminals. Connecting through ISDN, we couldn't run any meaningful applications. When the cost of computing became, sufficiently small, we made, the desktops, and we had desktops on the desk. And soon enough, it became difficult to manage them, right? And because connectivity now kept going up, we said, the heck with the desktop, we have powerful laptops and we have wireless links, etc. And that gave rise to VDI, make the laptop even, dummier, and all the compute is there because you have the bandwidth, the low latency. As the demand for bandwidth and low latency goes up, we are going back to similar cycles of technology adoption and evolution. So edge computing is, in many ways, not new really. We met that.
Definitely. Let's come to edge computing. I'm going to turn to Steve because he mentioned all these terms: millimeter wave, mid-band, what do these mean? Do I need to get a new phone? Like, how does my phone work with millimeter wave? Where are the antennas going to be? Where is the spectrum? Can you paint us a picture of spectrum in US versus global, China, Korea, Japan?
Sure, so I'll start with the US and then we can kind of talk about how it compares to the rest of the world. So with LTE, 3G, 2G, what you've been using all this time essentially is what's called sub-3 gigahertz spectrum. This is stuff like 850 megahertz that we used with CDMA that eventually became LTE. This is AWS, lots of terminology that's telecom. We have to have lots of acronyms. But it's all in this really interesting bands in the sense that it propagates well, which means it transmits well. It carries through walls. It carries through glass. It's a very attractive spectrum, but it's drying up in the U.S. in the sense that the last real significant auction was, I guess, a year and a half ago now with the band 71 or 600 megahertz. Mostly we're out of spectrum there, so we've had to move to other places to find what we can do. The other drawback of the low bands is while they transmit fantastic, this is why every movie you ever saw, there was a security guard in a basement somewhere with a TV with an antenna on it. It worked in the basement through concrete because it was the same bands that we're now using for LTE. The problem is it's very narrow band. So it's 10 megahertz, 20 megahertz, and so you kind of cap. So if you want to get to these massive data rates, you have to go somewhere else. So like I said earlier, you know, the average U.S. carrier in any one market will deploy perhaps 100 megahertz of spectrum total for LTE. That's everything thrown in. Some are a little higher, some are a little lower, but 100's not a bad number. When we talk about millimeter wave, we're talking about, this is microwave. So this technology has been used for microwave for years. The microwave dishes you've seen, satellite communications is where these frequencies have been used. We're now going to turn them around and use them for domestic use, but they're different. They're extremely wide, 800 megahertz, 1.4 gigahertz. These are 8x the total of LTE and 14 times the total. But the problem is they have a totally different propagation problem. They get blocked by everything. They get blocked by people, they get blocked by building construction, they get blocked by low E glass. So these are very different problems to solve. So now we're trying to solve with a huge capacity, but we've got a problem of how we get it to users. And so the design of the antennas in the phone, so it will require a new phone. It's a totally different technology. Phones are being built as we speak. You said earlier, you asked about when it's going to be commercial. We'll start seeing commercial builds this year at the very tail end of the year. And I think 2019 is going to be a pretty busy year for everybody in North America getting some millimeter wave out. It will not mean it'll be everywhere, but it'll be in a lot of cities and start to show up as a hotspot technology. It requires new phones. So we'll see the adoption of user devices as we go into the new year, but we'll start to see a few of them around the Christmas time frame, and then it'll kind of take off from there. I talked about mid-band. So mid-band is exactly as you'd expect. It's in this middle range. It's better propagation than millimeter wave. It's not as broad as millimeter wave. It doesn't propagate as well as the low band. So we're going to end up with this kind of three-tiered system in the U.S. You're going to have these high bands, which are huge capacity, but the problem is getting the signal to the users. That's going to be our biggest challenge, and we're working very hard across the entire industry to try to work through that problem statement. You've got the low bands, which are great, but they don't give you a difference in performance. The difference between 5G on a sub-3 gigahertz band and LTE will be essentially zero to you as a user from a performance point of view. You'll get access to other services, but the performance is flat. So mid-band is a nice thing. We haven't used it a lot in the U.S. Unfortunately, it was not the focus of the initial work by the FCC a few years ago, and so we're playing catch-up. So we're going to start to see what's called the C-band come along. It's 3.7 gigahertz to 4.2. Really attractive band. We need to get it into service as fast as we can. We have something called CBRS. You'll just start to see CBRS this year. It's really kind of taken off finally. In LTE, you'll also see 5G in CBRS. This is a 3.5 gigahertz band. The rest of the world is taking a little different approach. China is very focused on 3.5 gigahertz. Same bands as I'm talking about mid-band. So the good news is they will be driving while we're still getting it through the FCC and getting kind of ready. A lot of the industrialization will happen globally. Europe is also doing a lot of 3.5 as well. Japan's doing 4.5. So everyone's got kind of a different thing. So roaming is also going to be an interesting question for the next few years on 5G. Is there going to be any kind of international roaming in 5G? That's an interesting question. With all these different technologies and different bands, the different handsets, how quickly will that converge? So we'll see how that kind of works out. But In the US, we will end up with this three-tiered approach, and all the phones will ultimately have to support all three tiers. Some of them support two today, but we will see, you know, if you remember back to, I forget what year it was the iPhone 4, I guess, we had antenna gate, and if you held the phone the wrong way, you could lose your signal. Well, millimeter wave is going to be a version of antenna gate. If you turn your head the wrong way, you block the signal. So in a room like this, when you're used to putting up Wi-Fi, you put up one or two spots, depending on capacity requirements, and you get servicing everybody. You'll get service in your phone, in your pocket. You won't necessarily get that with millimeter wave. You may have to put up 4 or 5 heads because depending on the angle, you have to have relatively line of sight or near line of sight, it's called, with some reflections. So we're still working through a lot of that, but what it's doing is it's driving a different site solution concept. So we're building things smaller. We're putting massive capacity in them. We're going to build them smaller so that you can put more of them up cost effectively, but also from a SEG's point of view. Nobody wants to have a large antenna in their backyard. So this is why 5G is a really interesting challenge. We've got these technologies that are fantastic we want to bring to bear. We've got these challenges on the technology side to make them deployable, both from an economic point of view as well from an aesthetics point of view, because we're going to see more of these things in more places. We have to hide them and do all kinds of interesting things. Right now, you know, size is the challenge. So we're working through a lot of that. So we're going to see more innovation from now, I think, in the next 2 years than we have seen in the last 4 years, just because we're now at that tipping point. We've got everything working. Now we need to do a tremendous amount of optimizations to make sure more people get it in more places, cost effectively. Because again, nobody wants to pay a $200 cell bill again, right? We don't want to go backwards in that concept. So some of the recovery will be on the consumer side, but I think that the guys have been right. The real opportunity here is in the new opportunities, the new slices, not just doing more of what we've done with LTE, but having new use cases, new models, new ways to monetize this network for all the operators so that they can make it work as well. And then we need developers. We need people that are building interesting apps that are going to drive the ecosystem, because we're going to have a lot of tools in the toolbox to get a signal to a customer. Now we need people to drive the usage and find interesting, innovative ways to really make us continue to evolve what the platforms look like.
May I ask a question?
Go ahead.
Steve, Steve, can you comment on, you know, the software-driven transceivers in the 5G radio, telephones, so that, you know, if I buy a telephone in the US from Verizon Wireless, and I move, you know, I travel to Europe, where millimeter wave is, you know, supported on, you know, the Deutsche Telekom network at a different band, how am I going to adapt my transceivers of, you know, my modems to be able to roam?
Yeah, that's continuing evolution. I mean, today, if you look at your average high-end smartphone, the number of bands they support, if you ever want to look on the list for your Android phone or for a Samsung or for an iPhone, you'll see there's a huge number of global bands supported today. The innovators on the chip side continue to drive some fantastic support for bands. We'll see that drive continue, but we're also seeing that drive towards software, both on the handsets as well as on the network side, and that will happen as well. We're also seeing less control on the edge of the network in some ways, but we're also putting a lot of intelligence in the end devices as well, because these millimeter wave signals, one thing you'll hear a lot about over the next little while in millimeter wave, if you're interested in it, is beamforming. And beamforming is the technology that makes millimeter wave work. If you just turn it on in the corner at low power, it doesn't go anywhere. It kind of just wallows. If you crank up the volume, you start to hurt people. So you've got to find this middle ground where you use pencil beam technology and beamforming and these things. So we're actually driving a lot of compute at the edge just for that. So lots of interesting things to solve, lots of compute going on everywhere. Everything's becoming more software driven, right from the edge of the network and into the handsets. So I think that's how we'll ultimately solve the roaming issue, is just with brute force. So tremendous amount of compute in the UE.
Wow, I mean, this 5G thing seems very complex. The more we peel, the complex it gets. Let's jump into mobile edge computing. So we have cloud computing, AWS, Azure, everything is fine. So 5G comes along and says, we're going to build an intelligent edge network. Why do we need this? What is it going to do that I can't do on AWS? Operators tried deploying cloud computing systems before, it just didn't work. How will mobile edge computing change the landscape?
You know, I'll start for a minute and I'll hand it off. I think there's a couple of things that are interesting in mobile edge compute. in the past, when you try to do the same thing as somebody else is doing, it's very hard to compete. So if the offering is simply a different version of AWS, AWS is pretty damn good at what they do. They have massive scale. So there's nothing. What's going to differentiate here comes down to the use case. We talked about this acronym stuff, but this idea of latency is really fascinating. So latency essentially is the response time from the network to you. And today we measure it in internet kind of concepts. So if you do a connection to a server in the internet, it can be 20 milliseconds, 30 milliseconds. It can be a lot longer than that depending on where you are, response time from the server that you're measuring. When you're talking about industrial processes, you're talking about running robots. There's a safety system, one that we're working on with a partner, where they have to have a 1 millisecond response time for the kill switch. So as they want to automate the factory, obviously, if something goes wrong, they have to have a high-speed wireless response to shutting down the systems. The old way that we did it was we ran a whole pile of Ethernet cables all over the place, and we have to have a person standing next to every machine, basically waiting for the kill switch. Now we can do this remotely because you can do what the guys talked about earlier with, put the compute in the data center, strip down what's actually on the floor, get rid of all that Ethernet cable so that you can retool the factory much faster and get these super low response times. So it's a different offering, I think. If we are offering AWS in a different way, it's just competing with AWS, and it better be faster, better, and cheaper. But this is a totally different animal. This is enabling things that you cannot possibly do on a standard internet data center. It's nothing that they can control because they don't control the access, and the internet is the internet. So this is where I think it really gets different, where MEC is a different thing. Don't think about it as just standard compute at the edge. This is going to be highly specialized service offerings on the edge of the network. And it becomes really fascinating when you think about this because mobile edge compute, if you start having to have a mobile application, it's one thing to do a mobile edge for a fixed factory floor. But if you're actually going to enable it in a car, you have to worry about mobility, which means handoffs and maintaining the low latency. And if it has to be high reliability, you're talking about geo-resiliency, which are already fascinating problems we've got to solve. So this is a very different animal, and I think that's where the differentiation is going to be. It's a different class of service that can be offered.
So let me give you 3 examples that we are in various homework trials. Actually, I'll give you an example of why you need mobile edge compute. Some of them are public, and I can tell you the names, and some of them are actually will not talk to the partners. But in China, we are working with the operator and the car manufacturers, and they are actually in. This is a government-funded project, but they are doing smart roadside units for a whole around 200 kilometers to begin with. So those are nothing but intelligent base stations, also the distributed core UPF. And what Essential is doing, there's the cars, these connected cars, is actually turning on the cameras. They are actually mapping the roads. Then is that the data to the actual the roadside unit and processing it here and creating a map of that area. So essentially, if you look into any autonomous computing, there are 2 things. Obviously, you're going to make the decision in the car itself, so that's sensing. But then you have to have a functional duplication of everything. So it has to have a HD map that actually goes hand in hand with the sensing. That's not the Google map. That's actually a very low-level map that actually you map it on top of what you are sensing. And they say, okay, both these systems are okay. They're saying the same thing. I try. So that mapping element of it is essentially what these smart roadside units are doing. And what do they have? They have a 5G base stations under 6 gigahertz, so it's sub-6, so they don't worry about millimeter wave at this point. And we are installing this, and essentially it's completely virtualized base station. There's some of the cores that we virtualize to do UPF and some of the analytics and other functions. That's one example. Imagine that there's some centralized somewhere in AWS. The other one, this is public. You Google it, you find it. With a mining company with KDI and NEC, we did that in Japan. That's actually that's machine that earth movers. You talked about it in a lot of data, a lot of camera to locate the position of what to do where. And the controls is going to the downlink, essentially say, hey, pick it up, move it there. So those things can be there in some of the remote areas, disaster recovery, if the earthquake or something, you have to move the elements of it to find, stuff. So that's another use case. And third one, back here in Levi Stadium, these stadiums, you look into these games, I mean, if you look at localized, say, for example, a college football, a Stanford game, probably more interest in the people that are staying locally here on the data about this than, say, an ACC area like in Atlanta. So what do they do? If you go to any of these college football, any kind of game, they want to use Wi-Fi, pulling the statistics and stuff like that. You won't get even the signal. So they're bringing in the localized statistics about the players and others localized to the stadium. So these are some of the use cases that will require this mobile edge compute. So again, connectivity and compute together, and traditional, that centralized kind of data centers, or even network architecture where you used to move the data from the base station to the core. Core used to be centralized. Even that model may not work because of the amount of data that needs to get transferred.
Thank you. You asked the question why AWS cannot do the same, right? And I cannot help but recall a white paper I wrote 15 years ago, and one that I'm writing now, very similar essentially. Back then I wrote a white paper internal for our company with the title, and we gave it to some customers. Why Gym is bad for you, and Gym stood for Google, Yahoo, and Microsoft. That was 15 years ago. Today that is a different business. And I'm in the process of completing a white paper again for internal consumption primarily, and I may publish some of it with the title of The Cloud is Dead, Long Live the Edge. And I firmly believe that the challenges that the operators are facing in 5G are challenges that AWS and Microsoft and Google are going to face. If we assume that we have applications and use cases that require low latency, high reliability, and the mobility aspect, AWS will have to take their zones and bring them very close to Palo Alto and very close to San Francisco, and all of a sudden we have a new paradigm of edge computing, right? Otherwise, they will be left behind in the verticals that require the so-called edge computing, the low latency, which is necessary for a number of business reasons as well. For example, 5G, in any wireless and very expensive infrastructure, you cannot afford to have millions and millions of devices uploading upstream data all the time. So you have to aggregate the data, optimize data, do the most you can do locally, and then upstream, send upstream only what is necessary to do the deep learning or to do, to store it in the permanent, Hadoop database, so that you minimize your cost as well, and you minimize the demand on the shared infrastructure. If we flip the question and we ask the question of why AWS cannot offer what every operator can offer today, the answer is they can, and that's why I wrote the first paper. I was talking to my customers back then saying, if you don't move, Google is going to eat your lunch, right? Because they can go buy spectrum, they can become a global, very powerful mobile, virtual network operator, and they can do it anytime, in principle.
Okay, a few comments touching on some of the things that were just said. So first of all, if you go look at the Microsoft Azure website, you will actually see mobile edge compute section of the website. So they're not standing still. They're ready, because something like that, the equivalent of allocating resources at the edge, is very similar to what's happening on a smaller scale in the cloud, and they know how to do that. So that part is happening. Another thing that was touched on was stadiums. So for people that have been to stadiums or concerts, you look at your phone and it's just not working well, but you see full LTE coverage. So what's going on there? This is the density that we were talking about earlier. There's too many people in the same place. These systems were not designed, the 4G systems were not designed to support that. And companies have addressed this in very innovative ways using these distributed antenna systems, these DAS systems. They provide better coverage, but they don't provide greater capacity in some sense. They make sure that you can get some increase in capacity. But really, the next evolution in this, which is happening in 5G in release 16, is the use of multiple antennas. Not in the same way as traditional DAS systems, but in terms of advanced joint processing and pre-coding the signal. And when you have many distributed antennas, you can take advantage of things spatially. So that's it's an idea that's been around in academia for a long time. There are some companies that have made some progress on it, but it's never happened in a large scale. That's being addressed to some extent in release 16 in 5G, and there's still plenty of room to grow. If you can imagine having antennas everywhere and you have very low latency, real-time ability to analyze and think of those antennas as sensors. Now it's really just a sensor network. The concepts that have been around forever. The final thing that I wanted to mention that had been touched on was on latency. So I think since the start of 5G, maybe 5 years ago, you heard these numbers bandied around 1 millisecond, 1 millisecond, 1 millisecond. You've got to have 1 millisecond. And then over time, there was some pushback. Okay, well, maybe we don't need 1 millisecond for everything. What do we really need? But still, it's sort of drumbeat of 1 millisecond. And people would say, they've really tested it. Well, cars need it. Need it for autonomous driving, need it for car-to-car, vehicle-to-vehicle communication. And I recall at the first 5G kickoff within 3GPP, GM, one of the leads from GM R&D came and said, no, we think 10 milliseconds is probably fine. They're at 100 milliseconds right now with DSRC, which is the Wi-Fi based approach. So you have to really understand the specific application and dig in to see what's really required. Because the difference between achieving 10 milliseconds and 1 millisecond is massive. It can make a huge change in reliability and the number of users that are supported. Another example is, I know I keep mentioning VR because it's kind of fun, exciting application. You can see it. VR actually has there's a real implication on latency, maybe not in terms of danger like driving, but in what they call motion to photon latency. It's the time from when you turn your head and the sensors know how far you've turned and there's a new scene. It has to get the information back to the renderer. The new rendering of the image has to be done. Remember, now we're talking 2K, 4K, 8K, 120 frames per second moving forward. And then that has to be encoded and through the codec, the video codec, transmitted, decoded, and then displayed. And all of that, for at least what I've seen, it's the general consensus around 25, 30 milliseconds. So you might think, okay, well, that's plenty of. But each of those things that I mentioned chews up a big chunk. And at the end of the day, when you look at how much is left just for the wireless piece, because the codec piece takes up a bunch as well, in terms of the encoder and the decoder, you may only have 5 milliseconds left. So, and that's end-to-end latency, up and down the stack. So, I guess my point is, there are applications that may require 1 millisecond, where there's danger, safety requirements. But there are also other ways to do that. In terms of robotics, you can have the safety localized. So some robotics companies will not allow that piece to be removed to the edge. The sensors, the real-time sensors that are determining if there's a baby walking in front of the robot, that's not going to the edge. That's happening within a few milliseconds on the device. But all the other processing, navigation and sensors and video and things like that can move to the edge and have 10, 20, 30 milliseconds.
Computing. Absolutely not. Nobody knows today how to offer. AWS offers greengrass. If you call greengrass edge computing, if that means that I have to go, install my greengrass in my data center, no, thank you. That's not edge computing. And again, we have I don't think there is a unique definition of edge computing. But if you really look at, the state of the art, first of all, we have to make to come to an agreement that we cannot talk about all of these technologies unless we talk about virtual, software-driven infrastructure. Otherwise, all bets are off. Today, and I'm proud to say that VMware wrote the book, we know exactly how to do virtualization in the data center. Completely software-driven, software provision and managed data center. And with SD1, we come close to starting the journey in the distributed enterprise. When it comes to one and stitching together different, ones together to create a nationwide edge computing infrastructure, we have no clue how to do it. And that's the state of the art today. Look at AT&T's M-Cord initiative. They talk about taking the central office and distributing the central office to potentially 100, they're talking about 20,000 POPs, to 100,000 data centers, micro data centers. That's edge computing, right? And again, I go back to what I said earlier. If AWS and Azure and Google and SoftLayer and everybody who plays in the public cloud space want to be the edge providers, they will have to really follow the that game. I mean, they have to physically take their data centers and distribute them. We don't have a good model today of how to globally manage software control such distributed infrastructure, which also requires the centralized overall control, the centralized arbiter from the SDN control point of view.
So I have a couple of questions, but I know it's 7:45. I want to turn it to the audience for the Q&A session. Any questions? Okay, I see one hand. I'll have to share the mic.
Okay, that's probably good timing. This morning AT&T announced that they are bringing 5G to 12 cities. And because we have Verizon here, they also made it very clear that their 5G is standard-based and Verizon is running a non-5G standard out. So, well, I'm happy to see roaming and compatibility. That anybody has an answer what it would mean if Verizon is not international standard-based?
I can start, but we have a Verizon person here as well.
Yeah, that's why.
Because I've worked on both the standard, by the way.
Okay.
So even before the 3GPP, 3GPP 5G NR, which is supposed to be the standard, is 15, came along, Verizon took the lead and had this 5G TF spec, 5G task force, it's a big name, but for 1.5, 2 years, well, we worked closely with Verizon, and not just Intel, Qualcomm, Samsung, Nokia, Ericsson, all of the players, to actually come up with a spec and to actually prove out. What it did is essentially proved out a lot of those kings and technologies. And there are some of the deployments that Sir can talk about it, but I believe now that we are all moving towards a 5G NR spec, and to basically get into a standard implementation. But Verizon did a huge service to actually proving out a lot of those technologies that we actually, even before the standard came out. You want to add something?
I mean, you pretty much covered 99.99%. So for 2 years, Verizon ran the Verizon Technical Forum, where all the technical aspects are worked through this consortium, which is pretty much all the same people who were in the 3GPP. And then did the field trials 2015 to 17. So the idea was to get ahead of the market and iron out all the problems, come up with the solutions. So, I mean, it did help the whole industry a lot because everybody learned from that as well. So, 3GPP standard was finalized, I think, last December. So now everything will be upgraded to 5G NR. If people, folks don't know what NR is, it means a new radio. That's the new standard. So 2019, everything will be moved over, and everything will be interoperable. I mean, right now, the deployments we have are in 4 cities. So that's more on the first use case, fixed wireless access. So you don't really need to interop with other operators yet. In 2019, everybody is going to NR.
Yeah, I think when you hear these comments, it's really important, as you've heard here today, that there's different verticals. You have to stop, and when somebody says to you 5G is this, you've got to say, well, which part of 5G? Because here we might be talking about completely different things. Verizon is deploying and driving millimeter wave for fixed wireless access. And as Serhad said, you don't need interoperability. That's their own system. Think of it as a replacement for fiber. Think of it as a replacement, an alternative to the cable company, right? What goes into the phone, that's something completely different. What goes into an industrial environment that's, let's say a Walmart or a Costco that's just on the devices themselves, that may be different too, because it's not like you're going to walk in with your cell phone and expect to connect to this, expect to talk to the robots and the edge computers. So I think you have to be careful when somebody says 5G is this. If you ask different operators around the world, they will tell you different things for what is 5G to them. So what may be important in the US to Verizon and AT&T in showing millimeter wave, you go ask Deutsche Telekom or Vodafone, they may not be thinking about that as their first use case. They're thinking more about the 3.5 gigahertz band, which again, as was said before, could have been an LTE band, but it was really optimized in 5G. So there you have 100 plus megahertz of bandwidth available. You have a lot of new use cases, different ways that they're used in the US and outside, but there's a lot of bandwidth available, and that's 5G band technically as well. So you have to ask what it is.
So, okay, great.
Hi, I'm Clara Cherian, HP Ventures. So we talked about how big corporations like Verizon, AT&T, Google, Microsoft can play in the 5G market, but what are the biggest opportunities for startups to accelerate the deployment of 5G and play in the market as well?
So I'll take a crack at that. So in my mind, I see 5G as a new platform for any developer, anybody who's building an application. So think of it as a platform where you have multiple levers. And I think maybe the best applications for 5G have not been built yet because the startups don't know what it is, and we're trying to do the 101 education here. So think about, you have almost infinite bandwidth and almost zero latency. We talked about 10 milliseconds, but in the stand it's actually 1 millisecond. Just to be conservative, we say 10 milliseconds. So you can say, okay, I'm going to write this application, robot application, blockchain application, whatever it may be. You can think of, okay, I'm going to need this much bandwidth, pull this lever. I'm going to need this much latency. I'm going to need some grand slicing. I'm going to apply some mobile edge computing. So these are all parameters on the platform that you can use to optimize your application. If you go back to 3G days, moving from 3G to 4G, people were thinking, what am I going to use this for? Maybe I'll download pictures faster. But now, 10 years later, 8 years later, we're seeing Uber changing the whole mobility industry, Airbnb. I mean, you can say social networking grew on top of 5G. I think the best 5G applications are yet to come. It's just still an emerging technology, but you can consider all these components we talked about as APIs or part of your SDK that an app provider on top can call on and call the right one in the right combination at the right time to write their application. And that's why we have the 5G labs in Cambridge, New York, Palo Alto, to work with the people on those kind of applications, because we want them to build around us, build with us rather than around us. So that's my take.
We have to say that in that game, Verizon is ahead of the industry, of your competitors, right? Because I don't know of any, with the exception of a couple of European operators, certainly nobody here domestically is thinking that way, right? Creating, pushing basically the envelope of technology evolution and inviting innovative startups to come and become part of the ecosystem, right? Many operators tend to be stuck in the, all times of dealing only with the major nets, sorry, Steve, but, and Sunny giving out the true disruptors and true innovators. And eventually, they're going to miss out.
Just to add to what basically you asked for the D application, some of the stuff that we are working with the software ecosystems, things like cloud gaming. You essentially have, as Sarah was talking about, that you have the, basically network characteristics in front of you. How much latency you want, what is the TTI, what is the, how much cache, how much processing, what you need, and then you can actually design some of these applications, running some of them at the edge. So think of that it's providing you a huge amount of data connectivity. What do you do with the data? Video analytics is another example. we are working with the City of London to actually developing some of those, and we are working with third-party software. We are not designing those software. We are working with the software ecosystem players to actually design some of the software. So you get in smart cities, an example, connected elements, connected the smart meters and stuff like. You have a lot of those data that is coming from machine. What you build the intelligence on top of it. Cloud gaming is one great example that a lot of momentum we see that is happening, in the software ecosystem.
Yeah, cloud gaming is the one that you're seriously looking at, augmented reality, immersive media,
volumetric capture, immersive calling. We've been in the 2D world for a long time. I think 5G is going to enable a lot of interactions in 3D. Think about your FaceTime call in a 5G world, all in 3D. Holograms sound a bit far-fetched, but actually, when 5G is really deployed 5 to 10 years from now, it's not going to be far-fetched.
Yeah, you mentioned some limitations and restrictions with this technology. For example, if you want to use it inside the building, those communications could be blocked. So for one thing, I see this as a major problem. Are there good solutions for this? Like, if I want to use my cell phone on 5G inside the building, do I need to have an extra antenna inside my room or house? Or what are the solutions to fix it?
Can I take a crack at it? I'm not a radio expert, but the answer is, eventually we'll solve that problem. Steve made it look very difficult, and it is. But where I see the value of 5G is, again, in the cloudification of the infrastructure, the agility to deploy new services, right, and therefore open the ecosystem to innovation. Serhad mentioned Uber. If you really think about Uber, it's just a smartphone application, right? And it creates an entirely new industry. It's incredible. And you can point to others, other applications like this. But I like to think of 5G as, the classical, either new radio or, whatever band you support at the millimeter range and, lower bands, but also with Wi-Fi, also with other access protocols, If I find a way to aggregate all of this and have software-driven controllers in the radio access, we might be able to solve some of the problems of propagation.
The question was some of the millimeter wave propagation and real problems. I have some points, but I'll let Steve first.
So I think there's a couple of different answers to the question. So, will you get effective indoor coverage from an outdoor millimeter wave base station? The question is, the answer is actually, I can't tell you that, unless we know the building type, the window type. So the average question is, you will not get indoor service from outdoor nodes in any great percentage of coverage, and certainly not with every room in your house.
But compared to LTE,
well, so if you look at that 3 tiers I talked about, where there's the existing LTE bands will be converted to 5G, so the performance will be the same. There's this high band, which will have an issue that we have to solve, and I'll come back to how we solve that in a second. And then I really believe that the mid-band is a nice compromise where we will, between the 3 of them, that's where I think we do agree on this virtualization idea. 5G will be about managing multiple access types rather than just one. So it may be high band, mid band, and low band in combination. And the network combines them for you to provide the service because everything is kind of virtualized, and the only real hardware piece is the actual radio unit. There are some concepts we're looking at for how you can effectively do millimeter wave indoor. We're a ways to go. I will say that for large open spaces, we have relatively good solutions that will happen quickly. If you're talking about an enterprise with low ceilings and long corridors and cube farms, those kinds of things, I think that'll take some time before that will make economic sense. It's not the technology so much at that point. I talked earlier about we have to make these units smaller so you can deploy more of them very cost effectively to overcome the natural propagation issue. And that's the balance we haven't quite reached as an industry yet, just because we're very early in this whole process that we're driving towards. So I think it'll be a combination of answers. So one is specific to millimeter wave, indoor coverage from an outdoor radio, it's going to be very spotty, I guess would be the answer. Some places it'll work fantastic, but in lots of places it won't. And so we have to have this combination of answers. So I think managing spectrum is something that's different in 5G. In 4G, it's very specific to the spectrum that is LTE. I think one of the things about 5G is we will use different access types. I'm not a big fan of Wi-Fi for a lot of this, just because it doesn't work at scale, but it's a fantastic in-building, so it'll probably be part of the mix as well for consumers. But millimeter wave indoor is a little bit farther away in the classic sense. And then do we ever get there economically? That I don't know yet. We do have some interesting concepts that are working, but you have to get the economics right before you can compete. Otherwise, you just put a 5G modem on the side of the house, like the fixed wireless, and you run Wi-Fi in the house, and you basically have the advantages of both. So I think we have to find that economic sweet spot that we just haven't got yet.
Can I ask one more?
Add on one little piece. As I think I mentioned it earlier, just because you may not get millimeter wave coverage inside the house, it doesn't mean that you're not seeing the benefits of 5G, right? And just be careful of what you mean by 5G. So you may not be directly getting the benefits of millimeter wave because you don't have coverage inside your house, unless you put up antennas throughout the house. Not going to happen anytime soon. But what I mentioned before is you have this offload effect for the network. So let's say my phone supports millimeter wave and sub-6 gigahertz, and I'm inside the building, and I move outside the building, and I'm going to move for coverage of a small cell, millimeter wave small cell. So I move on to the millimeter wave network. People inside now have more average capacity. And keep in mind that LTE with carrier aggregation can already support more than a gigabit per second. So you're not going to really see a difference, any fundamental difference anytime soon. If somebody has a gigabit per second and somebody goes outside and they can do 2 gigabits per second, unlikely you're going to see something. So there'll be an overall benefit to you with greater coverage and more consistent higher bandwidth, even if you're not using the millimeter wave portion of the spectrum directly.
Hi. Yeah, interesting discussion. I have two questions. First one is carriers are really known for providing enhanced broadband services, right? Like phone kind of services. You're talking about 5G where it has multiple verticals that it services outside of mobile broadband, things like massive machine type, things like that. What makes you think carriers will be successful in doing any of that stuff? They've not had any background in it, and it is carriers never succeeded with enterprise, really, right? That's one. Second, enterprise use Wi-Fi everywhere. They use, when it comes to industrial type of things, Sigfox, LoRa, there's a plethora of other wireless things. 5G sort of tries to wipe all of that out. But spectrum you need spectrum to really operate in 5G, other than the CBRS, which is very tiny. How do you see these things coming together? Because technology is one thing, but reality is something else here in terms of deployments.
I would say the two questions are actually related, and they have to do with the quality of the spectrum. So, what is it that an operator has in their spectrum that you don't have in a Wi-Fi spectrum? You have some level of guaranteed service. And if you're using Wi-Fi and it's acceptable now, it's not acceptable for some of these. I can tell you for sure, working with customers and partners we're working with, it will not work in some of these applications like robotics and AR/VR, where you start, where your head-mounted display starts glitching because it takes you out of the experience. And the reason that's happening is because it's an unlicensed band. So what the operators can bring is the licensed band that can be used, around the world. But your first question is the key question. It's not known yet. I think there's still there's a gap between what the factory equipment manufacturers are used to and the security and safety in their zone and where operators want to go. Because this is where I think much of the great opportunity is in terms of revenue expansion for the industry is in some of these new verticals like industrial IoT. So there has to be this meeting of the minds between the operators and the enterprise, industrial users, the traditional users. But that is happening. That's been happening for a while. There's many consortiums around the world where these two are coming together because the operators are bringing something that they have that's incredibly valuable, this licensed spectrum.
Is it really an operator thing, or would it be enterprises deploy 5G on their own, independent of an operator?
Yeah. Right, and that will be good for your campus. And then when you drive away from your campus, you're lost, right? So I think that that's a great question, though. I tend to defer also when it comes to 5G because I think about the network, which starts at the access point, at the antenna, and goes all the way to the server that you access in the internet across, or to your peer that you connect to, if you use Skype or Zoom or whatever. So I look at that part of the infrastructure. And I believe eventually we're going to get to the point where the radio on your cell phone will be transmitting at different bands and will be adapting very smartly in conjunction with the network, right? And I believe with what Anton said and Steve and everybody earlier that we'll find ways around. Shannon's law notwithstanding, we'll find ways to both cram more into its band and work around the propagation delay. But operators, your question of why operators, right, instead of the enterprise, instead of somebody else, they're simply much better positioned to offer 5G services. If we look really, because you need massive scale, you need presence geography, not to mention owning the spectrum, a huge valuable resource, right? The only other players in that market that potentially, theoretically, can make it happen are the big public cloud, 2 or 3 good names that you know, right? So the operators know how to operate global infrastructure, interoperate with other operators, and taking that away from the operators is going to be very, very difficult, if not impossible.
We've got one last question before we're doing a raffle.
Hi, thanks very much for all your feedback. Just a quick question. My name's Tom Camp. I'm with Verizon Ventures. But a quick question on monetization of these services that we're talking about. Great overview on architecture and use cases and all that, but I don't hear a lot on monetization. And I'm curious if you think that network slicing would be one of the principal influences on that.
I believe it's going to be the solution that will make monetization of 5G possible. You're asking the wrong person. I live and breathe network slicing. And actually, not in the classical 3GPP definition, in an end-to-end fashion, what I call virtual service network, the ability to stand up a completely virtualized network infrastructure with all the VNFs orchestrated and make it happen with a few clicks, in 15 minutes, not in a year. Part of the 5G, I forgot the working group, that is, I think, ITU driven, has a mandate to bring, the time for provisioning a new APN, a new virtual operator, essentially, from 9 months to 9 hours, I believe, right? And they also say, network slicing essentially will be the way to deliver that value. And offer enterprise services, true, rich enterprise services.
So network slicing is an underlying technology that provides that. I'll give an example, a direct example of how the monetization I'm seeing happening. In Japan, NTT has given in Tokyo areas around 4,000, they call it GCs, group centers, to over-the-top internet merchant, which I don't want to name. They are bringing in their CDN and elements. So that group centers are hosting the base stations, the distributed code, the UPF part of it, and the content distribution data in there. So they are actually running the network, and this is just getting built. 2019, next year, middle of this will be first set of deployment. So you already can see that this 4,000, this becomes a mini small data centers. And these over-the-top players are actually paying the money because they want to bring in those OTT applications into that centers and run it because the density is so much, the data being collected so much. So that's some of the examples of how this is happening.
I guess one thing I'd add to it is my fear is that slicing has become this crazy marketing term that worries me. It's a fantastic enabler for all the reasons mentioned. It is absolutely critical and a fabulous enabler of 5G core actually achieving what we all hope it will be, which is to do different things. But at the end of the day, what will be sold to a customer will be their service provided in a better, faster, cheaper way. So we're not going to sell, it'll be very rare. Maybe in a wholesale scenario, you will sell a slice. What you will sell is a fundamental business tool, just like you do today as a company, but you can now offer it in a totally unique way with this rapid provisioning, end-to-end capabilities, guarantees that we could never give before because the radio was not part of the slice. You could slice the core sort of, but the radio wasn't involved. So we need to really back away, in my opinion anyway, that slicing is not something that will be sold to an end customer again, except in a very rare situation. You're just going to sell them a great enterprise service that you can enable at a fantastic rate of speed and cost model for the operators. And that's where I think it gets really unique. And to the point earlier about, is private 5G going to matter? It will. So private LTE is a really interesting thing, and it's actually offered and managed by the carriers today. I think managed 5G was the same way with enterprise, and you can mix that with a slice, and you have a fantastic thing. So I think slicing is great, it's a great tool, but again, let's not lose sight of what we're going to sell. Customers won't buy that, right?
It's about time to go home, but I totally disagree. We'll get to the point, not next year, not in 2 years, but we'll get to the point where an enterprise will be able to go specify to Verizon the type of service and network and VNFs they want, the dimensioning of it. 10,000 users, 100,000 users, and Verizon will stand it up, and it will also give them a management interface so that Enterprise X will look at the network as if they own it, except that that network is going to exist on Verizon infrastructure.
So good news is we have much more to discuss, but we've ran out of time. That's why we said this is the first event of a series. We're scratching the surface. So I'm going to turn over to Ravi. Thank you very much for the panelists sharing their wealth of information with us.
I have three things, so I'll do two and then we'll wait for the thing. So first is a quiz for the audience. With one microphone, what do you think is the best position to have? Think about it. I've got another question. Second is, I got an edge story for you. So in 2015, we started a company on the edge. This was the kind of the cloud is everything kind of era. And so we reached out to a big kind of guy from the Hadoop world and Yahoo and said, hey, we'd like you to be a founder of this edge company. He asked, are you going to next start a mainframe company? That's what people thought about the edge. Today, we have a company, Photon, that has 16 industrial OEMs. And so edge has really come a long way. So we first like to do this raffle. Why don't you? No, I'll hold it. No, you. Yeah. And just tell us about this raffle. What is it?
So we are TIBCO and generously raffling off a Ring doorbell security system set, which comes packaged with an Amazon Echo Dot. And the winner is...
Amazon is everywhere.
6687091.
Oh, wow, cool. So, thank you. So I want to thank first the audience for some amazing questions and your participation and for coming today. And this is going to be a series of events on 5G. So, and just based on the interest today, I think we're going to have a stimulating conversation for across this whole series. And I'd love to thank Serhad for moderating this, Anton, Christos, Yes, so Constantine, Udayan and Steve for this kind of intense discussion. So join me in